Hi, everybody, and welcome back to the EBI seminar series on the bioeconomy. Today, we're going to be having a discussion with UC Berkeley professor of mechanical engineering, Tarek Zohdi. Tarek Zohdi joins us to discuss the intersection of agriculture and AI, what digital twinning is, and how that can help the seaweed supply chain. Thank you for watching and enjoy. Hi, Professor Zohdi. Thank you for joining us. How are you today?
My pleasure. I'm doing well.
That's good to hear. Okay, so to start off our conversation, can you tell us a little bit how you came to the intersection of AI and agriculture?
Well, I grew up in Louisiana, which was a relatively rural place, and both of my parents were engineers, and I was always fascinated how technology and engineering could affect agriculture and vice versa. And so it was always something that had been brewing in my mind. As a mechanical engineer, I slowly started to appreciate the nexus between food, agriculture, and high tech, and how it's such an integral part of our society. And so that was the natural evolution, was that from a childhood of being around engineers and a area where it was very agriculturally based, it was sort of natural when I came to California to have that kind of a mindset. So little by little, that's where the evolution started with that genesis.
Okay, perfect. And today we're going to be talking a little bit about seaweed farming and how AI can be applied to that. How can AI and drone technology improve the harvesting process for seaweed farming?
Well, drones have become now almost ubiquitous in every aspect of our society. I look at them, in their most primitive form as flying cameras. And if you had a camera that you could fly around and take pictures of anything, that's more or less what a low-level drone does. Of course, it could do other many things, but for the purposes of, let's say, seaweed farming, it gives you the ability to inspect in every different nook and cranny, even in the subsurface of an algae farm, for example, penetrating into the water, checking to see the growth of the algae, looking for toxicity, checking in different spectra. So you can, of course, have LIDAR in some cases. You can have wavelengths of light that go all the way from, let's say, 1500 nanometers down to 200 nanometers, which is ultraviolet. So you can start to look at many different possible aspects of a seaweed farm that you could never look at before. So drones open up the ability to more or less probe, and multi-drones even more so, that over extremely large swaths of land that are not easily accessible, you can check to see how the products are evolving, whether there are any biotoxins, whether there's anything going wrong with the infrastructure. That's what drones allow you to do.
Okay, and from my understanding, your research focuses on digital twinning. Can you explain what that is for us and how it's applied for the harvesting process?
Sure. A digital twin is essentially a digital replica of a physical system that you can manipulate in the avatar or digital world and try what if scenarios that might be risky, long term. You can accelerate time over many years, decades, in fact. You can do things that you couldn't do in the physical world and test out the what if scenarios. The interesting thing about it is now that digital twins also allows you to take information from the physical world and feed that back into the simulation world and vice versa. So over the last, let's say, decade, there starts to become a symbiosis that it isn't just simply living in an avatar type world, but that the avatar world controls the physical world and the physical world feeds back into the avatar world. So you can test things like, what if we use these kinds of nutrients? What if we grow the algae farm here? What if there is a deep freeze? What if there is some local toxins, released by an oil spill? All of those different scenarios we can test out to see how our system will respond. And so that allows us to have a tool that we can look over extremely long time scales to determine what the implications are of what we're doing.
So, with the implication of drones, that always brings about like associations of like super advanced technology and stuff. So, I'm curious, how easy would it be for farmers to implement something that seems like such advanced technology?
Oh, it's become quite commercialized. So the wonderful thing about this is several drone companies have really tried to make drones super simple to manipulate and use now. 10 years ago, only a very skilled person could fly a drone. Now you can buy these off of Amazon and you can get an extremely high-end drone that anybody can fly within 1 hour. So it is no longer something that is just sort of the experts in the domain of only experts. It's opened up everything, and it's as simple as using an iPhone. So the beauty about it is now that you literally can connect your iPhone to a typical drone module and be able to fly within an hour, taking pictures of all of your different infrastructure. So a typical drone operator does not have to be super skilled anymore. And that's, of course, where, for farmers, especially small farmers, that's pretty critical because they don't have the manpower to have a dedicated drone person. Everybody needs to be, the drone person. So in my conception of how this is evolving, almost everybody that works, let's say, in an agricultural facility will be drone conversant, that they have the ability to fly a drone out and look at a far end part of the farm, maybe that's 50 acres away, or that is something that has something to do with bad weather, or they're looking for some lost item, or they're trying to scan for, let's say, penetration due to criminal activity in an area, or they're trying to just simply monitor the health and the welfare of the farm. All of those things anybody can do now with a commercial drone.
Drawing it back to seaweed production, you've briefly talked about the unforeseen consequences that might be addressed with digital twinning, but can you tell us more about how digital twinning or just AI drones in general can kind of mitigate these unforeseen consequences of seaweed production in particular?
Absolutely, because again, seaweed is a competitor with other, species in the near coast. So we don't want to inadvertently affect, adversely other types of seaweed fauna, animals, shoreline plants, even shipping, leisure of people. We don't want to turn everything into a gigantic seaweed farm or algae farm. So our idea is that digital twins can see the unforeseen consequences of what happens when an algae farm starts to evolve. Is there anything that changes in the toxicity of the water? Are there any unseen consequences of potentially harming people's livelihood, fish? Is there any possibility of affecting, people's ability to enjoy the coastlines, because of algae? Oftentimes you'll see these things called red algae that, occur periodically when the toxicity of the water becomes, dangerous. So generally speaking, we have the ability now to test out things that otherwise would take decades to see what the ramifications are. We can fast forward that in a simulation world.
Well, that's all really exciting to hear. That does it for all of our questions. Are there any last sentiments you want to leave us with today?
No, I think that, one of the key things is that, our world is evolving in a way that the nexus or the intersection between drone technologies, simulation technologies, and agriculture are here to stay. And with a growing population planet-wide, we really need to start thinking about these high-tech solutions as not necessarily a luxury, but a necessity, so that we can basically live in a cleaner and better fed world that is more nutritious, that we allow our global citizens the ability to have livelihoods that we can help put forth with our types of technologies that we're developing at EBI and in general, in this endeavor.
Okay, well, thank you for joining us today. This was a really interesting conversation and super informative. So we wish you all the best on all your future endeavors. And again, thank you for joining us.
Thank you. My pleasure.
Thank you for checking out the EBI seminar series on the bioeconomy and the seaweed supply chain. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on the macroalgae bioeconomy. Be sure to follow along for future installments or check out our previous series and explore social media, which are all linked in the description below. Thank you for watching and see you next time.